We all know large language models are incredible, right? They can write poetry, they can sling code, they can explain just about anything. But they have this one big weakness. They're basically frozen in time, stuck with whatever data they were trained on. So how do we connect them to the real world, to what's happening right now? Well, that's what we're going to get into.
So here's the fundamental problem. An LLM's knowledge has a cutoff date. It can't just, look things up. It has no idea what happened in the news yesterday. It hasn't seen your company's latest report, and it's totally in the dark about any fast-moving industry. And this is where you get those infamous hallucinations, answers that sound totally convincing but are just plain wrong or completely made up.
The solution to this is actually pretty brilliant and surprisingly simple. It's called Retrieval-Augmented Generation, or RAG for short. The big idea is instead of trying to stuff all of the world's information into the model itself, which is impossible, we just give it a library and teach it how to look things up before it gives you an answer. It's such a simple concept, but it's a total game changer. It makes the AI's answers way more accurate, up-to-date, and honestly, more trustworthy.
At its heart, the basic process is like a simple three-step dance. First, you index your knowledge base. You take all your documents, chop them up into manageable pieces, and store them away. Second, when you ask a question, the system retrieves the most relevant little chunks of info. And third, it bundles your question and those chunks together and hands it all to the LLM to come up with a really smart, informed answer. This simple blueprint, that's what we call naive RAG.
So for this explainer, here's our game plan. We'll start with the RAG revolution itself, then we're going to break down the key stages: pre-retrieval, retrieval, and generation. And to wrap it all up, we'll take a peek into the future, which is something called Agentic RAG.
All right, let's look at how we go from that simple, naive RAG to something a whole lot more powerful. You see, people figured out pretty quickly that while the basic idea is great, the results can be a little hit or miss. The quality of the final answer is completely at the mercy of the quality of the information you retrieve. Garbage in, garbage out, right?
And this picture shows that evolution perfectly. Over on the left, you've got that basic, straight-line process. But look at the right. That's advanced RAG. It adds these clever new layers before you retrieve anything, like cleaning up the data, and after you retrieve it, like reshuffling the results. This all makes sure the LLM gets only the best, highest quality info. These extra steps, that's where the real magic is.
Okay, so first things first. You can't just throw a messy pile of documents into a database and hope for the best. Think about it. If you gave a research assistant a disorganized stack of papers with coffee stains and doodles all over them, you wouldn't expect a great report, would you? The very first step to a really powerful RAG system is to get that library organized.
And just look at this. When you pull data from a web page, you don't just get the nice, clean text. You get all this junk. HTML tags, bits of code, navigation links, ads. This stuff is what we call low-density information. It just clutters up the system, costs more money to process, and waters down the actual facts, making it way harder to find what you're actually looking for. But now, watch what happens when we start cleaning. We start with a whopping 55,000 tokens of that raw HTML mess. A simple script can strip out the obvious junk and get us down to 1,500 tokens. That's pretty good. But the real leap is next. We can use another AI, like GPT-4, to go through and pull out only the core facts. And boom, we're down to just 330 tokens of pure, concentrated information. And we're not talking about a small improvement here. As this quote shows, using an AI for that final cleaning step can shrink the data by another 5 times. That means your system isn't just cheaper and faster to run, it's way more effective because it's only searching through the good stuff, the actual signal, not all the noise.
Okay, so our library is squeaky clean and beautifully organized. Awesome. The next big challenge is making sure our AI research assistant can actually walk over to the shelf and pull out the perfect book. This is the retrieval stage. And, you guessed it, we have some really clever tricks to make this part a lot smarter.
One really great method is called hierarchical indexing. Basically, instead of having the AI read every single page of every single book, we have it scan a list of summaries first. It's like glancing at a table of contents to find the right chapter. Once it spots the most relevant summary, then it goes and dives deep into the full text. It's just so much faster and more precise.
Now, this next technique is one of my favorites because it's so backwards, it's brilliant. It's called HIDE, stands for Hypothetical Document Embeddings. Here's the crazy part. Instead of searching for your question, you first ask the AI to just make up a perfect answer, a hypothetical one. Then you take that imagined answer and search for real documents in your library that look a lot like it. It turns out an answer is often more similar to another answer than a question is, and this little mind trick can dramatically improve your search results. Wild, right?
So we've cleaned our data and we've found the perfect documents. We're pretty much done, right? Well, not so fast. There's one last place this can all fall apart. The AI might have all the right facts right in front of it, but still write a bad answer. This last step is all about polishing the information we found before the main AI even sees it. Two key tricks here are reranking and compression. So reranking deals with this weird quirk where LLMs pay most attention to the stuff at the very beginning and very end of a prompt. So a reranker just shuffles the documents to put the most important ones in those VIP spots. Then there's prompt compression, which is like having a helpful editor. It uses a smaller, faster AI to trim out all the filler words, making the context shorter and way more focused. Now, a question I hear all the time is, hey, isn't this the same as fine-tuning? And it's a great question, but the answer is no. They really solve different problems. Think of it like this. RAG is like giving your AI an open book test. It provides facts from the outside world. Fine-tuning, on the other hand, is like teaching the AI a new skill. It actually changes its internal behavior, like its personality or writing style. You use RAG for knowledge, and you use fine-tuning for character.
This chart lays it all out perfectly. You've got basic prompt engineering down here, which doesn't really require changing the model or a ton of external data. RAG, you can see, is way up there on needing external knowledge, but it doesn't really change the model. Fine-tuning is the complete opposite. It's all about adapting the model, but it doesn't need that external library. And of course, for the ultimate system, you can absolutely combine them.
So with all this complexity, how do we even know if it's working? Well, we measure everything. We look at retrieval quality, things like hit rate, which basically asks, did we find the right document at all? Then we look at generation quality, with metrics like faithfulness, which asks, did the final answer actually stick to the facts we gave it? You see, it's a two-part challenge. You have to find the right stuff, and you have to use it correctly.
Everything we've talked about so far has been a pretty rigid step-by-step pipeline. But the real future of RAG is way more dynamic. It's about taking our solo research assistant and turning them into a whole team of experts that can actually think and plan for itself. And that brings us to Agentic RAG. Instead of just following a script, retrieve, then generate, an agentic system gets a goal and a whole toolbox. It might have a tool to search our private database, another tool to search the live web, and maybe one to look up stock prices through an API. The agent itself gets to think and decide which tools it needs to use and in what order to get you the best possible answer. One of the big frameworks for this is called ReAct, which, you guessed it, stands for reason and act. It creates a kind of thinking loop for the AI. First, it has a thought about what to do next. Then it takes an action, like using one of its tools. It observes the result of that action, and then it thinks again, repeating this whole cycle over and over until the job is done. And this isn't just a small upgrade, it's a huge paradigm shift. We are moving from that rigid assembly line to a smart, dynamic system. It's really the difference between having a library card and having a smartphone with a full suite of apps. It's just more flexible, way more powerful, and it can handle problems that are much more complex.
And that really brings us to the final thought here. We started this whole journey by just trying to solve the problem of outdated knowledge by giving AI a library. Now we've evolved that into a dynamic agent that can not only read from the library, but also browse the web, use a calculator, and plan its own research strategy. The next frontier isn't just about finding facts anymore. It's about synthesis, it's about critical thinking, and it's about genuine reasoning. And that is a future to be really excited about.